Almost done with this part of muscle physiology. We're looking at two ideas today. One, the whole idea, and one, an intro for tomorrow. We're starting off with skeletal muscle actions, how paired muscles can interact, and how one muscle is described in terms of points of attachment. Starting with that, we've got an origin and an insertion for each muscle. If you think of the word origin, it's where something starts. And the origin of a muscle is where it starts. We're doing the proximal distal thing. We're saying proximal end. Closer to the torso is the origin. Another way to look at that is that the origin is the less movable end. The end of the muscle that moves is the insertion. So if you look at an arm, there's an arm. The insertion is going to be here at my shoulder, an anchoring point for the muscle. We'll talk about the biceps, the muscle on the front of my arm. If I contract my biceps, it's my lower arm that moves. That's where the insertion is. The part of the joint that moves is the insertion. Hand. Origin's going to be here in the forearm. What moves? The wrist. So my insertion must be on my hand. If you ask a little kid, where's your muscle in your arm? They're going to tell you here. Where is it? It's right here. But really, it attaches at the top. And for movement to occur, you have to have force below the joint. So that's the idea with origin and insertion, and that's why I like the diagram in your packet, the physicsy diagram over to the right, because it's showing the arm as a simple machine. Diagram at the left is showing biceps, triceps, which is really cool. That's nice. Notice biceps, 2 heads, 2 points of attachment. Triceps, 3 points of attachment, 3 heads underneath your arm. But the diagram at the right showing the weight being lifted, the load, the fulcrum of the lever. It's a pretty cool diagram if you know simple machines, showing where the biceps attach in the forearm in order to lift that load. So that's important in terms of how muscles act on joints. Muscles work together to create a repose motion. That makes sense because if I bend my arm, I need to be able to straighten it as well. If I were to flex my knee, kick my leg back, I'd need to be able to straighten it. When I go up the steps, I take a big step, I flex my hip, and then I extend my hip. Paired motions, we talked about that in Unit 2, the skeletal system. Flexion, extension, medial and lateral rotation. We talked about pairs. So muscles are paired too. You have your prime mover or your agonist. I don't really like agonist because it sounds like agony and there's no pain involved in this. Prime mover is the muscle most responsible for flexing or extending or rotating. It's the prime mover of a joint in that it makes the motion. It's the primary source of motion. You might think that the one in your arm is your biceps. It's actually not. It's a muscle that runs along the biceps called the brachialis. So let's talk quadriceps. If my quadriceps are my prime mover, what am I doing? I'm kicking my leg. So when my quadriceps are acting, I extend my leg. I straighten my leg. That's good. There are other muscles that help. And those are called synergists. Synergy is like a business term too. It means to work with, to work nice with. The synergist, if you're talking about a muscle, works with the prime mover. So I told you the biceps isn't your prime mover of elbow flexion. Your brachialis is. Your biceps is a synergist to that. It works with the brachialis. It works really well. It does a lot of the work to flex an elbow. Antagonist. I always think of literature when I think of this, and I'm not the English person, but I learned this in sophomore English, that the antagonist is the bad guy in your plot. There's nothing bad about the antagonist in terms of muscles. It undoes the motion of the prime mover. So the prime mover has flexed the arm. The antagonist, my triceps, extends it. But if I'm saying that the motion I'm talking about is extension, then the antagonist to the tricep would be the brachialis and the bicep. It's the thing that undoes. And that's muscle action. That's origin, insertion. Origin near the torso, insertion where something moves. And prime mover, synergist works with it. Antagonist opposes it. How you define prime mover versus antagonist depends on what motion you want to talk about. Tomorrow, we're going to go into 3 types of muscles, or next time, we're going into 3 types of muscles: smooth, cardiac, skeletal. The muscles we've talked about so far in this packet have been skeletal muscles. Striated, acting when you want, moving bones, doing their thing. But you have 2 other types of muscle called smooth muscle and cardiac muscle. Cardiac, pretty easy. If you look at your comparisons here, we're going to talk more about those tomorrow. Location of smooth muscle is going to be walls of hollow organs. Guts are what I think of. Squishy guts. Stomach, intestines, squishy guts. It's other places too, but that's what comes into my mind. It's in your lungs. It's a hollow organ thing. And we're also going to talk about it as part of your eye, what it can do for your eyeball. Cardiac, heart. Pericardial cavity. We've done cardio as heart before. And your skeletal muscle is what we've been talking about, attached to your bones, doing your thing. The most important difference, I think, among these muscle types, and there's some pictures showing you a little bit about them, and you can see that they look different. Those neat striations, those neat bands in skeletal muscle aren't anywhere else. You get kind of stripy in cardiac, but not so much. And smooth muscle, to me, looks like a pile of slugs. It looks like slugs swimming with a common purpose. So with that, if you look at those, you can see the differences among the cells. We're going to talk more about those tomorrow, but the big take-home message for today: voluntary versus involuntary. If you do something voluntarily, you do it because you want to do it. If I make you do something, it's involuntary. If I say, hey, I've got this cool anatomy test to take, and you're like, awesome, give that to me. I say, you don't have to. You say, but I want to. It's voluntary. If I go, you need to take this test, and you go, I don't want to, and I say, you need to, and you go, okay, that's involuntary. Muscles, similar but not quite. Voluntary muscles, you got to want to make work. I see my phone right now. I want to pick up my phone. That was a voluntary response. My brain said pick up the phone, so I did. Right now, as I'm talking to you, I'm breathing. I'm not thinking about breathing. If I had to remember to breathe, I would have a problem. Because I don't remember, like, if my dog is in or out of the house and she's large. Like, I lose the dog. She's massive. If I had to remember for my heart to beat, I would forget. How about this? If you had to think about breathing and your heartbeat, you couldn't sleep. If you had to think about digestion, I'd still have the food in my stomach from last Tuesday because there's no way I would remember, hey, digest that food. No, you have processes in your body that are involuntary. It's not the same idea. It's not that I don't want my heart to beat. It's not that if you're like, should your heart beat? I'm like, no, thanks. Yeah, these happen, but your brain controls them. Or in the case of your heart has control over itself. So, voluntary is skeletal muscle. You have to want it to move. I want to stand. I want to be waving my hands and talking to you. Involuntary, while I talk to you, I breathe, I digest, and my heart beats. Involuntary. So in terms of classes of muscles, skeletal is voluntary, cardiac and smooth are involuntary, and we'll go back to that tomorrow and look in more detail at cardiac and at smooth muscle. And then that's it for the physiology section of this chapter. We're going on to anatomy next. Have a good one.